Let's move on. So I'm starting with the first lecture, that is Introduction to Machine Learning. So this is part of the Fundamentals of Machine Learning course of this semester. Then see, when we, in this particular, you can say the lecture, I'm going to cover what the various applications that we see around, all around, that is machine learning in the real world. Then this machine learning, how it is different from the traditional programming. Right, when we write a simple program we have been writing, then this how this program is different from the machine learning program. Why do we really need machine learning? What kind of problems are there that can be solved using machine learning? What is machine learning? Then the types of machine learning, supervised learning algorithms. Then see, because these days we are talking about advanced machine learning, or we are talking about, you can say, the deep learning algorithms. Since you are studying the machine learning course, so you should be well aware of how this machine learning is different from the machine learning, deep learning, and at what time, for what kind of applications, in what kind of scenarios deep learning will be more suitable as compared to the machine learning. So in what kind of situations we should go for, you can say, the machine learning algorithms, and in what kind of situations should go for the deep learning algorithms. And I'll be just giving a brief overview of the various deep learning architectures which are existing. So that is just for the sake of your knowledge. So that is not part of the syllabi. So you should, because you are going for this field, that is understanding and going through the machine learning. So if you talk to someone and somebody asks you a particular question related to machine learning, then you should be able to answer how it is different from deep learning, and what are the various architectures available, and which architecture is suitable for what kind of problems. So this is the, you can say, the overview I'm going to give about the deep learning architectures. We are not going to get into the details. This is just to add on some knowledge for you. So when we talk about, you can say, the artificial intelligence, see, machine learning is basically an artificial intelligence techniques, and artificial intelligence, it is a broad domain in which we try to imitate the behavior of human beings. What is the behavior of human beings? Basically, when we talk about, so if we consider the human beings as an agent, then in that case, what are the various senses that we have? So well, you can say we have a sense of vision, we have sense of hearing, we have sense of smell, then we have sense of feel, touch, that we say. So all the artificial intelligence techniques, they are basically trying to imitate all these behaviors of the human beings. So that's why we say the artificial intelligence, you can say the artificially intelligent agents, they have certain sensors and they have certain actuators. So what are these sensors? Basically, these sensors, you can say, they are imitating the behavior of human beings. You can say whatever sensors you have seen, they are either, you can say, imitating one of our own senses. You can say they may, if you talk about computer vision, we are talking about the eye, the vision part. They are trying to sense the behavior. They are clicking the pictures, and then on the basis of that, a certain task is being performed. Besides that, when we are talking about learning, how do we learn? See, when we are talking about, we say human beings, we are the Homo sapiens. That means the intelligent beings. So the intelligence part of the human beings that comes, that is how do we think. So that is being imitated into the machines, so they become artificially intelligent machines. So how do we think? How do we take the decision? How do we analyze the things? How do we remember the things? So all these different abilities that make us intelligent, all these, you can say, the hardwares and the software agents, everybody, all the scientists are trying to imitate such kind of intelligence. They are trying to embed in the hardware as well as the softwares. So they are artificially intelligent systems, we can say. And machine learning is one of the, you can say, the is a special type of machine learning. Machine learning is basically a kind of artificial intelligence technique where we are trying to imitate the behavior of the human beings, that is learning, how we learn. So in the real life, you have seen we learn through experience. So in the real life, if you see, if I show you some picture that you had never seen, you will never be able to tell me that what is this picture, right? So similarly, when we want to know, when we want our machine to tell what is this picture, whether it is a car, it is an apple, it is an orange, it is a truck, any kind of picture you want your machine to recognize. So you, first of all, you have to tell that machine, you will have to make this machine learn through examples, like we have been taught in our learning. Like when we were the small kids, you, if you can recall, when you were studying in the nursery class, KG class, or you were at home, when you were a toddler, your mother was telling this is an apple, and after some time you started recognize something that is a round or oval in shape, something that is red in color, that means it is an apple. So who told you that the mobile that is you are using is a mobile? Someone told you that this is a mobile, this is a, see what, how do you know the difference between a smartphone and the other device, the mobile which is not a smartphone and the mobile which is a smartphone? Somebody told you something, so that means that is learning by examples. Someone has shown you that example, that if you see or you come across something like this, that means it is a mobile phone, or it is a laptop, or it is a computer. So similarly, when we want our machines to imbibe that particular behavior of learning, we have to give them training. So when we are talking about training, when we are learning by training, we ourselves are learning by training, and machines can also learn by training. Then we talk about representation learning. Representation learning plays a very critical role when we are talking about the AI techniques. So basically, representation means how are you, see, when you want machine to learn, that if machine comes across a device, some picture of some oval shape, then it should tag it with a label that is an apple. Then how it is going to tag it? So that means it has to learn some representation. Representation means the features of that particular apple, so it has to do some kind of feature engineering. So in machine learning, this representation learning is basically done by a human beings. So human beings, the help of the human beings, or you can say the interference of the human beings is required, so that the machine learning algorithms can be applied after the representation learning. But when we automate the task of representation learning, then it is called as deep learning. That means in deep learning algorithms, the task of representation learning has been automated. That means now there is no more requirement of the human beings to do any kind of feature engineering. Deep learning algorithms do this particular task by themselves. So this is how the AI, the machine learning, representation learning, and deep learning are related to each other. So if you have any queries in between, you can just unmute and ask. There's no point, so you need not wait till last. So at any point of time, if you feel like asking any question, just unmute and ask the question. So then we have the various machine learning algorithms that we say. See, machine learning applications we are using everywhere, maybe knowingly or maybe unknowingly. So here we have, like you can say, when we are using the Siri or the Cortana in our mobile phones. So what kind of systems we are using? Siri is able to recognize our voice, so it is able to understand. You can say the hearing sense Siri has, and it understands a voice, convert that voice into the text, and then performs that particular activity that we want the Siri to do. So it is a machine learning application. Then we have machine learning translation systems, like when you are using the Google Translator, converting from, you can say, from English to Hindi to French or German, any kind of language translation you are doing, there also the machine learning is working behind that. PayPal is using the machine learning to detect the frauds. See, when the most common example where the machine learning is working behind that is the Google search engine. See, when you, so because you all are from the computer science domain, you must have written the programs of database connectivity, like using Java or PHP or any, even you can say the Python. So you have seen how much time, see, we say the most time that is taken by the application is in establishing the communication with the database. So with a small database also, when we write a simple query, we are not able to get the results in milliseconds. It takes seconds in the local system. But Google is giving you all those results, Google is serving millions of users simultaneously and answering all those queries within the few milliseconds or microseconds. So what kind of algorithms it is working on? So there are large number of algorithms the Google is working upon so that you are able to get the results within the few milliseconds or microseconds. Then when you find like certain recommendations on the Facebook that you can tag the friends, the machine learning algorithms work behind that, so they recognize the faces and just try to make you identify and tag those friends. Then we have self-driving cars where we have the deep learning algorithms and then reinforcement algorithms. These days we are sitting at home watching movies over the Netflix and the Amazon Prime. Then we are always searching for the recommendations, movies what others have seen. So we have a, you can see, one more tab over there where the recommended movies are shown. So all these, you can say, these are the recommendation systems. The recommendations are generated using the machine learning techniques. Similarly, you have the machine learning algorithms which are specifying, you can say, whether it is a mail or a spam. The filtering is done by these machine learning algorithms in your mailbox by itself, and you can also tag that, and that is the major part of that is also done by the you can say the algorithms which are already there working behind your mailbox. So similarly, you can talk about so many applications which are there which you are using, and behind those algorithms, this machine learning you are using the applications, and behind these applications machine learning algorithms are working over it. So traditional programming versus machine learning programming. So all of you know how to write a program. So any one of you can answer, what do we do when we write a simple program of if then else? Any one of you?
Well, it is logic. If we do this, otherwise we do this.
So in that kind of logic, what we are doing, what is the input that is given? What input we give? Let's say we want to
Condition.
compare the three numbers, right? So we want to compare the three numbers. Now I want to know what is the input you are giving.
Input can be a boolean
So
variable or a set of.
let's say we want to just compare three numbers and the numeric values we are giving A, B, and C. No? So I
Three
want to compare
integers.
three integer values. So that will be called as data. Yes.
Yes.
So we can call this as data, that the three values that we are giving for the A, B, and C. Then what are the rules?
The instructions, the if else statement.
Actually,
If this, then do that.
Yeah, we provide
exactly.
them.
Exactly. See, when we are writing within the program, if
Yes.
A greater than B, A greater than C, then A is the biggest, right? So these
Yeah.
are the rules that we are writing, isn't it?
Yes,
So when we are writing the traditional programs, so what we are giving input to the program is the data as well as the rules. And what the program gives us, the answer, we have given 3, 4, 5. According to the rules, the processing will be done. On the basis of that, it will give me the answer. The biggest number is 5, right? You agree with this?
yes, ma'am.
Okay. Then what will happen when we are working on the machine learning? What will change? Any guesses? See, we have these three things only, right?
Yes, ma'am.
So only the locations will change. Something will come on the left and something will go on the right. So what is your guess? What can happen?
Ma'am, the results.
The data will be
Results will be
input
input
on
over
the first stage, and on those data, the rules will be applied to compute the answers.
So this is already given. This is traditional
We give the
programming.
answers and the data, and we get the rules in return.
Yes,
yes, ma'am. Yes, ma'am.
just repeat. Just repeat.
Ma'am, we give the
We
data
input
and the
the data
answers,
and
and in return we get the rules.
yes, ma'am.
Yes,
We try
correct,
to guess.
correct. Actually, see, this is how the traditional programs, the simple programs, they are different from the machine learning. See, what is there is like, if when we are writing this small program of three numbers, it is easy to write down the three rules, right? But if, let us say, if I have to compare 100 numbers, and find out the biggest. Then how many rules we require?
Uh,
Just think over how many rules will be required to compare the 100 numbers.
that means
Yes? Anyone?
100 factorial.
100 factorial we can say. So these many comparisons will be required. And what will be the computational cost for that as the value of n is increased? And who will be able to write these number of rules? Understanding what was the problem?
Now
Yes?
we have to work on an initial data set of which rules will be made. Then we will apply those rules on the remaining data set.
See, actually the thing is, but first of all, you will have to write down the rules. For how many numbers it is easy for the human beings to write down the rules? There is a limit to that actually, right? So after a certain limit, it is you can say it goes beyond the capability of the human beings to write down the rules, right? So in order to solve this particular problem, what do? We go for the machine learning algorithms. So in the machine learning algorithms, what do we have? We are giving as input the data, then we give the answers, and then these machine learning algorithms, they generate the rules for us. And after that, these rules can be validated whether they are correct or not, as one of you said. So these rules will be tested on the new data, and then we will try to see what is the accuracy of these machine learning models in solving any kind of problem. Maybe it is a prediction problem, maybe it is a classification problem, it can be any kind of problem that we talk about. Clear? Any doubts over here? Yes?
No, ma'am.
No, ma'am.
Okay, let's move. So in the machine learning algorithms, the components are same, but the direction is changed. So machine learning algorithms, they take the, we give them as input answers and the data, and these algorithms, they generate the rules for us. Then when we are working on the machine learning algorithms, basically for applying any machine learning algorithms in the real world, first of all, it is very important to test the accuracy of that model. Like we are talking about these days, the vaccines for the COVID-19. These COVID-19 vaccines, many companies have already claimed that we have made it, and but the government and the agencies, the authoring agencies, they are not giving them permissions to be to make it a public, right? The thing is, they have not been tested yet. So for their testing, what do we do? See, this vaccine is new and we don't know what is the accuracy of that, how it is going to impact the human beings. And when we talk about the something related to medicine and that has to do with the life of the human beings, we cannot take the risk of making it public without any testing. So similarly, for any kind of machine learning algorithm, any kind of models that we develop, we are not going to make it public, or you can say we are not going to give it, it cannot be used in the real world without proper testing. And for proper testing, what do? See, in the beginning, we don't have anything which can say if something new comes up, how do we validate the answer is correct or not? So what do? Whatever, see, we are testing the performance of these machine learning algorithms in the benchmark data sets that we have. Whatever data we have, we divide that into two parts. One is the training part and another is the test part. So what we are doing, actually we have data, we have the complete data set, we are dividing that. One is for developing the model, that will be called as the training data set. Another part will be for evaluating the performance of that model after we have generated rules for that. So for evaluating the performance, this new data is basically, initially this new data is the test data that we talk about. And then when we apply those rules on this new data, and then we make the predictions. So then we compare the actual values with the predicted values. On the basis of that, we say we are computing the accuracy of this particular model, and then we say this is the performance of this particular machine learning model, that the model performs well with 70% of accuracy or 80% or 90%, whatever is the output. When we are talking about the medicine field, there we are talking about the specificity and the sensitivity. When we are talking about the marketing or information retrieval, there we also compute the recall and the precision. So many evaluation parameters we have that we can use for evaluating the performance of these machine learning models. So this is you can basically you can say that these things we do. See, testing we do with the traditional programming, but we are not dividing the data into different parts for traditional programming that we do in the machine learning algorithms. So what is machine learning? According to Arthur Samuel in 1959, it is a field of study that gives computers the ability to learn without being explicitly programmed. That means, see, are we programmed? If we consider the human beings, machine learning is from the field of AI, and we are talking about imitating the behavior of human beings. What are the things that are hardwired in the human body? And what are the things we are learning, learning from the experience, learning from the environment? So we are talking about the machine learning that you can say making the computers develop their ability to learn. That means learn without being programmed. That means we don't want to write down all the rules. Something, there are certain machines should be able to learn over a period of time and then react or act accordingly. Like when you are playing, so you people must be playing lot many games these days. So when you are playing the game, if you're playing against a computer agent or the software agent in the game, so you must have seen that this agent has learned a lot, and it is a very intelligent agent with you whom you are playing. It's not a dumb agent. So how do we get, see, you played the game for the first time, and see, whenever these games are made public, before making it available to the common man, to the players who want to play, these games are played many times, so that the software agent which is there in these games, they should be able to get the experience for any kind of actions that may be taken by the opponent. So this is how the, you can say, the software or the hardware agents, they may be learning over time. Then in 1999, your Tom Mitchell, these are the two famous definitions which are used in the machine learning. So according to the Tom Mitchell, it is a computer program is said to learn from experience E with respect to some class of task T. So basically, see, when we are talking about artificial intelligence imitating the behavior of the human beings, so the various agents that have been developed, the various agents that have been working, or we are using the AI machines, they are basically task oriented. That means they are meant, the agents, they are meant to solve only a particular kind of problem, or a particular kind of task. And the performance measure P, as I said, how it is performing. Then if its performance at task in T as measured by P improves with experience, so then we say, see, if the performance is improving by playing that particular game again and again, that means we can say the computer program is learning. So this is like I gave you one game of chess, and now you started learning. As many times you play that particular game, your game is improving. See, in the earlier you were only winning, maybe like you are winning 1 out of 3 games, then you started winning 2 out of 3 games, and sometimes all the 3 games. So repeatedly playing these games, you are able to learn. So similarly, these machines are learning when their performance is improving by playing every game. So here we can say E is 1000 games or 1 lakh games. So that is the experience. That means the agent has already played these many games. By playing the number of, with the increase in number of games the agent has played, his experience is increasing. And T is playing the checkers. It can be playing the tic-tac-toe. It can be playing your Fortnite. It can be your PUBG. Any kind of game you can say that is a task. of playing a game, or it can be any kind of task. And P, performance, whether you win or you not win or you lose. So depending upon your winning or your not winning, you can say on the basis of this performance, we can evaluate that whether you are learning or not learning. So it is the same kind of behavior that we do. So if over a period of time, if your marks are increasing, that means you're learning. If they are not increasing, your score is not increasing in a game, that means you are not learning. So the machine learning algorithms that we talk about, they are basically three types of categories they are divided into. One is unsupervised machine learning, another is supervised machine learning, and another is the reinforcement learning. So in the unsupervised machine learning algorithms, your clustering and the dimensionality detection, they basically come under this particular category. Then we have the supervised learning algorithms like your classification and regression. They come into this category. Then we have the reinforcement learning algorithms, which is based on the mechanism of reward and penalty. So most of the games are developed using the reinforcement learning techniques. So we will go into all these techniques one by one and looking at the various problems they are used to solve. So now I'm going to give you one real life problem and you have to guess what kind of machine learning algorithm can be used to solve this kind of a problem. See this, read this real life problem. There's a pizza chain wants to open its delivery centers across the city. What do you think would be the possible challenges? They need to analyze the areas from which the pizza is being ordered frequently. They need to understand as to how many pizza stores has to be open to cover delivery in the area. They need to figure out the locations for the pizza stores within all the areas in order to keep the distance between the store and the delivery point minimum. So resolving all these challenges include a lot of analysis and mathematics. Now, can you guess which particular machine learning techniques will be suitable to apply for solving this kind of problem? The problem is we want to open a new delivery center across the city. What is the appropriate location we want to location where we can open the new centers? So can you guess which particular machine learning algorithm can be used for solving the supervised, unsupervised?
Ma'am, clustering
Clustering
algorithms,
algorithms, unsupervised.
unsupervised.
Okay, good. Can you further elaborate?
Ma'am, we will find the
Would you like
clusters
to
of
further
delivery points.
elaborate a little bit? Answer is right, no doubt.
Ma'am, we will find the clusters where there are many delivery points. So we will find the clusters in the data that are close to each other. So we can store, we can establish a store where there are clusters of delivery point.
Yes. Then, okay, on what will be the information that we are going to use to create the clusters?
Ma'am, locations of the
Clustering.
delivery point.
Okay.
Ma'am, some locations
So,
they'll have the high delivery.
actually, yes, right. Exactly. See, what we have when we are talking about opening up user center, what kind of data they are taking from us? What kind of data they have about the users, which can be used for, applying
Frequency
the
of
cluster.
placing order in a particular area.
Yes. What else? See, when
Ma'am,
you are
an
placing
estimate
the
of
order,
income.
just recall when you place an order, all of you must have ordered pizza and you have given the information. Just recall what information they are storing in their database.
Our address,
Yes,
The frequency of our orders.
yes,
Amount.
okay. So what is the most important part?
address,
Address. See, here we are talking
Location.
about delivery center.
Yes.
On which
Food taste.
what is the appropriate location where we should open the center? Right. So what are the, see, when we are talking about applying the clustering techniques, the clustering means creating the groups, isn't it? And groups we create on the basis of similar kind of behavior. Here the users, what kind of behavior? See, they all are ordering the pizza, that is fine, that is the same behavior. But besides that, what will be more common between them? That is, see, mobile numbers, they can't be same, right? So we can ignore that particular mobile number field. Then their names, they are not going to serve any information. Only if we use them, they are going to increase the computational complexity if we use the names or the mobile numbers. Agree? Then
Yes.
what is important is the frequency of order which they are getting from a particular area and the address of that particular area, isn't it? So these are the useful features which can be used to find out. See, if we find out the, you can say, when we compare the addresses, and from these addresses we know the frequency also. So from there we can find out from where we are getting the maximum number of orders. More number of data points into one cluster they will fall. अगर एक एरिया से बहुत ज्यादा लोग ऑर्डर कर रहे हैं तो वो एक, यू कैन से, लेट्स से वी टॉक अबाउट सेक्टर 128 ओनली, ठीक है? अगर सेक्टर 128 और सेक्टर 93 को कंपेयर करें तो अगर सेक्टर 128 से ज्यादा ऑर्डर्स जा रहे हैं क्योंकि वहाँ बहुत सारे स्टूडेंट्स हैं तो उसमें ज्यादा डेटा पॉइंट्स आ जाएंगे, और सेक्टर 93 में मे बी कम डेटा पॉइंट्स आएंगे,
Yes, ma'am.
right? And from this we can find out the central points which we call as the centroids. कि अब पता चल गया कि हम एक सेंटर तो हम सेक्टर 128 में खोल सकते हैं और एक पिज्जा सेंटर जो है हम सेक्टर 93 में खोल सकते हैं, but within sector 128 is also not small, isn't it? So what within sector 128, what will be the appropriate location? We have to find out, right? For finding out the exact location, we find out the centroid of that particular cluster, and this centroid will represent the delivery center for this pizza chain. Clear? Anyone who is not clear, any doubts? Okay, let's proceed. So what do we do? What we have just discussed now, the same thing. What we have raw data. Raw data is about the users of the pizza chain center, the people who are placing the order. On this data, you can say what we have is the training data set. So these, you can say that different shapes, they represent the different behavior. So some people have same behavior, others have different behavior. So you can say all these shapes in the training data set, they are representing the behavior, or you can say they are representing the features. See, all the triangles are having the same kind of features, or pentagons or the hexagons, they will have same features. The squares will have the same features. So when we are going to apply the certain algorithm, all the algorithm, you can say all the triangles, they will come together because they are more similar to each other as compared to, see, one triangle is more similar to the another triangle as compared to a rectangle or a square or a circle, right? So when we apply the clustering algorithms, so in that case, after the application of any of the clustering algorithms, the complete data is divided into number of groups. So it depends upon the kind of clustering algorithm that you are using, whether you have to give that input initially. So that means before the application of the clustering algorithm, you should know that in how many groups you want to divide the data. That means it may be that you already know that in this particular city, let's say in Noida, you want to open the 5 pizza centers, and it may be that you don't know that how many pizza centers we should open. So in that case, you have to choose another clustering algorithm. So if so we have different clustering algorithms. Some clustering algorithms like k-means clustering, there is a prerequisite that you should know how many groups you want to create or how many clusters you want to create. So k-means clustering cannot work without that input. We have agglomerative clustering algorithm which does not require input of the number of groups or the number of clusters that you want to create. So depending upon the kind of problem you have, the kind of solution you are looking for, you can choose the appropriate clustering algorithm, and after the application of this clustering algorithm, you are able to get the clusters, and the central point of that cluster is called the centroid of that cluster. So this is how you can say the unsupervised. See, why we are calling it unsupervised? Because these algorithms are not getting any kind of feedback. Or any kind of feedback, you will understand. See, nobody is going to tell what is wrong and what is right. So whatever is shown to you, that is the learning and that is the outcome. So nobody is guiding this kind of learning. So we call it as unsupervised learning, learning which is performed in the absence of any kind of supervisor. Right. So another example is like you can divide the countries in the world map into developing countries, developed countries, or underdeveloped countries. That too, again, see, when you can say when we are applying these unsupervised machine learning algorithms, all you can say the data learns by itself by finding out the, see, when we talk about, let us say, the recommender systems. In the recommender systems, how you are getting the recommendations. So we have a data of movies which are being watched by the users. So what we can do is, see, for developing the recommender systems, the first stage, what we can do is, in order to improve the scalability. See, if I have to develop a recommender system and I want to know which movies I should watch. If we have millions of users and the system has to find out, you can say, the similar kind of users for me, right? So in that case, how many comparisons will be required? Can anybody tell? If the value of n is 1 lakh and I want to know the top 5 users which are closest to me, how many comparisons will be required for that? Anyone? Yes, Arjun, can you tell? Are you there?
Yes, ma'am, I'm here.
Can you guess?
Ma'am, arithmetic progression from 1 plus 2 plus 3 to 1 lakh.
तो अब अगर हमारा n 100 है तो हमें कितने कंपैरिजंस हो जाएंगे? पर यस
5050.
तो ये तो कितने हो गए? 100 यूजर्स के लिए हो गए अप्रोक्सीमेटली, राइट? अब अगर हमारे, वी आर टॉकिंग अबाउट द करंट सिनेरियो वेयर वी टॉक अबाउट द बिग डाटा, राइट? अब नेटफ्लिक्स के कितने यूजर्स होंगे? जस्ट अ टेंटेटिव आइडिया. How many Netflix users are there and how many Amazon Prime users are there? They are not in hundreds, nah? They are in lakhs, millions, isn't it? So if there are 10 million users and they are providing the recommendations for the movies, so that means you can imagine how many comparisons they will have to do. So that is not a scalable solution, right? Because that requires large number of computations. So in order to solve such kind of problems, what is being done is we can apply the clustering algorithms for the recommendations. What do? We divide that, let us say, let us say for 10 million users, we have to do 10 million comparisons. I'm simply taking that value, okay? Or and if we divide that into 5 clusters, or let us say we divide that into 10 clusters, all the users are divided into 10 clusters. That means when the new user comes in, we have to provide the recommendations of movies from any of these 10 clusters. So we have to simply do 10 comparisons. We don't have to compare the new user with all the 10 million users. We have to compare the new user only with the 10 centroids of these 10 clusters. So by doing these 10 comparisons, we are able to find out what is the best cluster from which we should provide recommendations to this new user. Now, from that cluster, see, out of the, let's say, 10 clusters, we have sidelined the 9 clusters. So you can say the problem is reduced to 1/10. Agree? So now we have to give recommendations only from the one cluster, and that is reduced in size, far more reduced in size as compared to the 10 million users, the complete size of one cluster that we had in the beginning. So developing using clustering algorithms is a very good solution for developing the scalable recommender systems.